We thought we understood stars. We thought we could measure, categorize, and predict. Yet, some objects laugh at our certainty. Stephenson 2-18 exists, 2,150 times the radius of the Sun, almost empty, burning fast, dying young. It is bigger than comprehension, yet lighter than expectation. A giant without mass, a furnace without solidity. Deep space exploration shows us cosmic phenomena that defy intuition, where limits of science collapse and unanswered questions of the universe multiply. What does it mean to witness something that could erase worlds and yet leave no trace of itself? Humanity in the cosmos is suddenly insignificant, a spectator in a theater of incomprehensible scale and indifferent brilliance. This is not just a star. It is a question, a challenge, a mirror of our own fragility. And as we attempt to understand it, we confront a paradox. The universe is both knowable and unknowable, vast yet intimate, indifferent yet intimately connected to us. Stephenson 2-18 is alive, yet almost nothing. It will exist, burn, and die without witness. And we are left to stare, measure, and wonder. Stephenson 2-18 is not merely large. It is incomprehensible. Its sheer scale challenges everything we think we know about stars. Cosmic phenomena like this push humanity in the cosmos to the edge of the known universe, where language itself fails. Words that once held meaning, giant, immense, colossal, dissolve under the weight of its reality. If placed where our Sun is, it would consume Mercury, Venus, Earth, Mars, and reach the outer bounds of Saturn. Every war, every love, every fleeting human ambition would vanish within its fiery expanse. Deep space exploration has revealed stars of vast proportions, but nothing prepares us for a scale that encompasses entire worlds. Scientific uncertainty becomes palpable when we try to imagine it. Imagine driving along its equator at 100 kilometers per hour, uninterrupted. It would take 5,000 years to complete the circuit. You would begin in the Bronze Age and arrive in the present, still circling the same star. Even time bends into the incomprehensible, offering only glimpses of how limited our perception of scale truly is. Unanswered questions of the universe multiply when confronted with this vastness. Every centimeter of Stephenson 2-18 dwarfs our intuitive understanding. Space discoveries have taught us to quantify and contextualize cosmic phenomena, yet here, all measurement becomes meaningless. Astronomy explained through traditional metrics collapses. The enormity of this star exists beyond comprehension, a reminder that limits of science are often arbitrary. Its radius is 2,150 times that of the Sun. Numbers cease to convey magnitude. Cosmic mysteries like this force a confrontation with the inadequacy of human language. We are observers, staring into a vastness that has no precedent, and every attempt to anchor understanding slips away into abstraction. The mind struggles to hold the image, a sphere so vast that history, civilizations, and dreams would fit within it, all consumed by its fire. Space storytelling often seeks awe, but here, awe borders on existential unease. Humanity in the cosmos is suddenly fragile, infinitesimal, and irrelevant against such scale. Stephenson 2-18 does not just redefine what a star can be, it redefines what large means. Scientific uncertainty stretches to the edge of our imagination. And yet, this is only the beginning. Its incomprehensible size hints at another layer of strangeness, one that is not measured in magnitude but in emptiness. Stephenson 2-18 should be dense, compressed under its own mass, a furnace of gravity and matter. Instead, it is almost nothing. Its outer envelope is thinner than air atop Mount Everest, a diffuse glow of energy suspended in near vacuum. Scientific uncertainty grows as deep space exploration uncovers this paradox, where cosmic phenomena defy expectation. Imagine stepping onto its surface. You would feel no solidity, no weight, only a searing, rarefied gas stretching for millions of kilometers. Astronomy explained in textbooks fails here. our understanding of stellar mass collapses when faced with a body so immense yet almost empty. Humanity in the cosmos is confronted with the impossibility of sensation. The star's density is incomprehensible. You could theoretically drift through it, yet survival is impossible. Not from crushing pressure, but from the unbearable heat. Cosmic mysteries like this expose the fragile limits of our intuition, revealing that even what we consider solid and substantial can evaporate into scientific uncertainty. Consider a balloon the size of our solar system, filled with air thinner than the emptiest vacuum of space, yet glowing with the brilliance of 440,000 suns. This is the paradox that Stephenson 2-18 embodies. Space storytelling rarely encounters such contradictions. Here, size and substance are divorced entirely. Gravity, expected to compress and condense, is somehow restrained. Limits of science cannot predict why the star holds together without collapsing into itself. Deep space exploration shows us that reality has loopholes our models cannot capture, and humanity in the cosmos is left to grapple with phenomena we can observe but not fully comprehend. A star so vast yet so empty forces existential questions. What does it mean for matter, for mass, for the rules we assume govern the universe? Unanswered questions of the universe pile up as we attempt to reconcile presence with absence, magnitude with void. Every photon radiated challenges the certainty of scientific models. Stephenson 2-18 exists in a state that should be impossible, a combination of scale without substance. Cosmic phenomena test the edge of the known universe and push deep space exploration into realms of contemplation rather than calculation. And yet, this state is temporary. Very temporary. Stephenson 2-18 burns its fuel at a rate that makes its existence fleeting. While most stars live millions of years, this cosmic phenomenon consumes the equivalent of Earth's mass every 25 days. Deep space exploration shows us that magnitude does not imply longevity. Scientific uncertainty swells when time itself seems compressed within its fiery envelope. Every second, millions of tons of matter are ejected in violent stellar winds. Astronomy explained in human terms cannot capture the immediacy of this destruction. Humanity in the cosmos feels inconsequential as we observe a star that lives fast, burns brighter, and dies younger than any ordinary comprehension allows. It is dying now. While you read these words, its fusion engines are consuming themselves in a brilliant, unstoppable blaze. Cosmic mysteries reveal that impermanence is not just a human experience but a universal principle writ large. The edge of the known universe includes events so swift that observation becomes almost irrelevant. If the sun's life spanned a century, Stephenson 2-18's existence would be a fleeting gasp. Born enormous, it will die young, leaving no witnesses to its brilliance. Space storytelling cannot dramatize the brevity of its life. It can only gesture at the impossibility, leaving us unsettled by the scale of temporal compression. Its temporariness challenges the limits of science. We cannot predict the exact moment of collapse. It could be tomorrow, or in 10,000 years. Unanswered questions of the universe remain unanswered, yet the certainty of eventual demise persists, reminding us that even cosmic titans are impermanent. The juxtaposition is unsettling. Something so vast, impossible in scale, exists only briefly. Deep space exploration is haunted by these contradictions. Humanity in the cosmos witnesses magnitude without stability, brilliance without endurance, presence without permanence. Existential questions multiply in the glow of a dying giant. Even the stars that dominate our imagination are ephemeral. Stephenson 2-18 embodies a temporality that renders human lifespans negligible. Scientific uncertainty meets existential awareness as we grasp that impermanence is woven into the fabric of cosmic phenomena. And when it disappears, it will do so violently. The end of Stephenson 2-18 will not be quiet. When its core exhausts its fuel, gravity will win instantly. Deep space exploration has documented supernovae, but none so unpredictable, so immense in scale, that scientific uncertainty becomes almost tangible. Humanity in the cosmos is powerless to witness or influence what follows. In seconds, the collapsing core will release more energy than the Sun will emit in its entire 10-billion-year life. Cosmic phenomena like this defy intuition. Even astronomy explained at its most precise cannot convey the violence compressed into a fleeting instant. Every model we have strains against reality. The explosion will be visible from Earth, naked eye perceivable for weeks. Yet no consciousness will exist to observe it. Unanswered questions of the universe loom as we consider the absurdity. One of the most spectacular events in existence will unfold without an audience. Imagine every bit of energy humanity has ever produced, from the first fire to all nuclear power, concentrated into a single second, then multiplied unimaginably. This is the scale of Stephenson 2-18's death. Space storytelling often seeks drama, yet reality here is beyond narrative, beyond comprehension, almost cruelly indifferent. We do not know if the remnant will be a black hole or a neutron star. We cannot predict whether the explosion will be symmetrical or chaotic. Deep space exploration confronts the edge of the known universe, where limits of science dissolve, leaving only speculation against the certainty of inevitable collapse. Even if Stephenson 2-18 had already exploded, its light might still be traveling, yet we remain unaware. Cosmic mysteries remind us that the universe is vast, indifferent, and beyond our perception. Humanity in the cosmos is humbled, confronted by phenomena that occur without regard for observation or comprehension. The star's death will be spectacular, yet utterly anonymous. Scientific certainty exists only in the inevitability, not the specifics. Its supernova is a reminder that cosmic phenomena follow the laws of physics, not the desires of observers. And even in this violence, something remains. Without stars like Stephenson 2-18, life as we know it could not exist. Cosmic phenomena such as this forge the elements that compose planets, oceans, and bodies. Deep space exploration shows that the death of a single star seeds entire systems, spreading matter across the edge of the known universe, beyond comprehension. When Stephenson 2-18 explodes, it will create carbon, oxygen, nitrogen, iron, gold, atoms that did not exist before. Astronomy explained in textbooks cannot capture the scale of creation embedded in destruction. Humanity in the cosmos carries the remnants of countless stars, unknowingly dependent on their violent legacies. Every atom in your body, aside from hydrogen, was forged inside a dying star. Cosmic mysteries embed themselves in our very being, linking human existence to scientific uncertainty, and to the impermanence and scale of deep space exploration. The boundary between observer and observed blurs in this realization. Imagine carrying within you the echoes of billions of years of stellar deaths. Stephenson 2-18, when it perishes, will create atoms destined for lives that will never know the star that made them possible. Space storytelling cannot dramatize this fully, yet the thought alone unsettles, forcing reflection on our place in the cosmos. We cannot know how many generations of stars lived and died to produce the elements on Earth. We cannot count how many Stephenson 2-18s exploded before our existence. Scientific uncertainty expands as we trace the lineage of matter, recognizing humanity in the cosmos as a consequence of events we never witnessed. Stephenson 2-18 is unaware of its role. It will not know it created life, or that remnants of its death will become part of futures yet unimagined. Deep space exploration confronts us with phenomena that act independently of observation, indifferent to significance or purpose. Its legacy is not conscious. It simply burns, it simply dies, it simply produces matter. Cosmic phenomena operate on laws, not intention. And yet, the atoms it leaves behind will carry fragments of impossible existence, seeding both the familiar and the unknowable. In this act of creation through destruction, we glimpse an uncomfortable truth. Scale, impermanence, and consequence are intertwined beyond human control. Stephenson 2-18 burns, dies, and leaves behind the building blocks of futures it will never witness. And this raises a question, one that stretches beyond even our imagination. Stephenson 2-18 existed long before we discovered it, and it will exist, briefly, long after us. Cosmic phenomena unfold regardless of observation. Deep space exploration reminds us that scientific uncertainty is often irrelevant to the events themselves. Humanity in the cosmos is a mere witness, not a participant. Discovered in 1990, the star had already burned for thousands of years. It did not pause, did not react, did not acknowledge our gaze. Astronomy explained through observation becomes almost a fiction when confronted with a universe that does not depend on our perception. Whether it explodes tomorrow or in 10,000 years, Stephenson 2-18 will act according to physics alone. Cosmic mysteries operate independently of conscious attention. Space storytelling, often centered on discovery, encounters here the uncomfortable truth. The universe proceeds without care for observers. Imagine the most violent event possible, one that dwarfs all human understanding. Now imagine it happening without an audience. No memory, no meaning, no consciousness to witness it. The edge of the known universe contains acts that are indifferent, vast, and unavoidable. We cannot know how many Stephenson 2-18s exist, or how many have already exploded unnoticed. Limits of science stretch thin against the backdrop of deep space exploration. Humanity in the cosmos is left with knowledge but no influence, observation but no control, comprehension but no significance. The star's existence, its burning, its collapse, continues in utter indifference. Scientific models may predict outcomes, but they cannot confer relevance. Cosmic phenomena reveal that our awareness does not shape reality. It merely attempts to grasp it. Stephenson 2-18 teaches a disquieting lesson. The universe requires no witness. Its brilliance, its destruction, and its legacy occur whether we are present or not. Unanswered questions of the universe remain, and perhaps they are meant to remain. It burns, it grows, it pulses, it dies. And at no point does our presence matter. The edge of the known universe holds acts beyond comprehension, where humanity in the cosmos is humbled and unsettled. And yet, even in this indifference, something persists. Stephenson 2-18 exists. 2,150 times the radius of the Sun. Almost empty. Temporary. Violent. And utterly indifferent. Cosmic phenomena like this violate our models, challenge our comprehension, and erase the boundaries we thought contained the universe. The more we learn, the less we understand. Not only about this star, but about what the universe allows to exist. Deep space exploration constantly confronts us with scale and substance that defy prediction, reminding us of the edge of the known universe and our limited perception. If a star can be this large, this empty, this impossible, what else might exist that breaks our rules? How many other Stephenson 2-18s remain undiscovered, burning silently, temporarily, and without witness? Unanswered questions of the universe multiply as we realize our observation is optional to reality. Stephenson 2-18 has no consciousness. It does not know it is extraordinary. It does not care that we observe. And perhaps this is the lesson: the universe is not trying to be understood. It simply is. And we observe, measure, calculate. In the end, Stephenson 2-18 will burn the same way whether we watch or not. Its fire, its collapse, its legacy, all unfold indifferent to humanity in the cosmos. Scientific uncertainty persists, and the questions only grow. Exists there a limit to what the universe can create? Or is everything we consider impossible merely undiscovered, waiting beyond comprehension? More questions waiting.